Electricity from lesson 12, the national grid, and lesson 13, static charge. Okay, so previous work, which should be done from last week. This week, looking at the national grid. So the national grid is a system of transformers, step-up transformer at the beginning, step-down transformer at the end, and the cables connecting each side. Okay, the design of the national grid is to transmit electricity across the countryside. The main part of the transformers, they are designed to change the voltage. So in the step up, so here somebody stepping up, increases the voltage going into the national grid, and at the other end we have a stepping down, so a person stepping down to decrease the voltage to houses and to machinery and businesses and industry. Okay, why we do that is to do with this equation: power is equal to voltage times current. So if I have 100 watts, that could be at 10 volts multiplied by 10 amps, which gives 10 times 10, 100. Or I could have done it at power 100 watts equals 100 volts multiplied by 1 amp. So 100 times 1 still gives you 100. So by increasing the voltage, you decrease the current, giving the same power output. So if we transmit it across the national grid, so here are our cables getting hot, so it transmitted at a high current, so high current, the cables will get hot and lose heat to the surroundings. Okay, we don't want to waste our energy by losing heat to the surroundings from the hundreds of miles of cables across the country. So what we do is we increase the voltage. So we got a voltage of about 330,000 volts, 320,000 volts, and that is transmitted across the countryside, which means the current is very low. So we got a high voltage and a low current, giving us the same amount of power. So less heat is lost, so basically a nice and cool. So this means the national grid is a efficient system, so it efficiently transmits the electricity. That means you do not lose energy in the transmission process, so less energy is lost. So high voltage, low current means less heating in the wires, which means less energy is lost to the surroundings. Okay, and that is the purpose of the national grid. Be careful, it is just the step up, step down transformers and the cables. Houses and power stations at either end are not part of the grid. Next topic is static charge. So with static charge, how do we get a static charge? Charged objects are charged by rubbing or friction. So if we have a rod which is rubbed by a cloth, what happens is the rod may become a negative charge, the cloth may become a positive charge. The rod is negative because it gains electrons, and the cloth is positive because it loses electrons. All static charge, all instances of any static charge are explained only by electrons moving. Okay, protons do not move, only electrons move. So become positively charged, you lose electrons; become negatively charged, you gain electrons. Then you need to know your rules, so you can have a way of remembering it. I've done yum and yuck here. So positive likes negative, so positive is attracted to negative, opposite charges attract. Or you could have that the same charge is positive, yuck positive, so positive does not like positive, positive repels positive, and negative repels negative. So like charges repel, unlike charges attract. And the key thing to remember, everything's explained by electrons moving only.